Hello everyone. In this video, I'm going to show you a very interesting concept of number system. Okay, so prime numbers, co-prime numbers. Okay, so what is co-prime actually? Okay, so I will tell you with an example, guys. Okay, let's say you have 6 chocolates in a box and 35 chocolates in another box, right? 6 and 35. So you want to divide these chocolates among a specific number of boys. Like you can take 2 boys, you can take 3 boys, you can take 5 boys, whatever you want. But you have to divide all the chocolates. I mean, all the 6 chocolates to these boys, okay, and all the 35 chocolates to these boys. You can't increase the number of boys, okay. Let's say we took 2 boys, then we can divide 6. Okay, so we can give uh, you know 6 chocolates to 2 of the boys. Each of the boy will get 3 chocolates. Okay, so what about the 35 chocolates? We can't evenly divide 35 chocolates among 2 boys. Okay, so we can't divide because only one chocolate will be the rest. Okay, so these chocolate has to be broken, so our condition is we can't break any chocolate. Okay, so it should be evenly divided, right? So you can consider some other numbers too, like 3. 3 can divide 6, but 3 can't divide 35. Okay, so 4 can't divide 6. 6 can divide 6, but 6 can't divide 35. So it's not possible. I mean, it's not possible to divide by other any number, both of the numbers. Okay, 6 and 35. You got my point, right? So now, when you can't divide any two numbers with any other specific number, okay, except 1, we can divide these two numbers with 1 only. Okay, so we can divide 6 by 1, we can divide 35 by 1. So except 1, if we can't divide by any other number, okay, so these numbers are co-prime. Okay, so you see, 6 is not a prime number, uh, and 35 is not a prime number. Okay, we can divide 6 by 3, we can divide 6 by 2, we can divide 35 by 5, 7, but they are co-prime. Okay, so I hope you got the point how co-prime actually works. Okay, so here we're going to see the program, guys. Here we are taking two integer values. Okay, so printf enter two numbers, so user will give us two numbers. Scanf will get the input here, and if find gcd, so find gcd function will be in action here. So in the previous video we saw how actually this works, right? So if we put uh, a is 35 and b is 6 or whatever it is. Okay, so if you give vice versa, however you provide, you will check. If you check here, what you can do for this video, as I showed you in the previous video, you can write in a paper or you can write in an MS Word file. Okay, so try to visualize this problem, uh, this function with 6 and 35 and see what you get. Okay, so if it's uh, find AB. Okay, so if it's 1, if 1 is the highest number to divide them, then the numbers are co-prime. Okay, otherwise the numbers are not co-prime. So if we want, we can visualize this function. Okay, so will you do it, or I will show you? I hope you will show me, but you will check on your own. But you can pause the video and you can you can check it, and maybe after that you can watch my video. Okay, do it. So a equals 6, and b equals 35. Okay, so while loop, we will pass a 6 and b equals 35, and fast iteration, b not equals to 0. Okay, so 35 not equals to 0, so it will go into the loop. Let's say, let's write it again. While 35 not equals 0, you may think that I'm just spending more time, but if you visualize it, it will really help you guys. Okay, the more you visualize, the more it will be clear in your brain. Okay, so temp equals to b is what, 35, right? And b equals a modulus b, right? So here 6 modulus 35 will give us 6. Okay, 35 doesn't go in 6. Okay, so 6 will be the modulus, and a will store temp, right? So temp is 35. Okay, so now uh, this was the first iteration, guys, and for our second iteration, it will be b will be 6, right? So b not equals to 0, it's true, and temp would be 6, and a modulus b means b is 35. I'm sorry, guys. A was 35 and b is 6, right? B is 6, so it will be like 6 multiplied by 5, right? So 30, and so modulus would be 5. Okay, so a would be 6, right? So now what is b? B is 5. So here it was our second iteration. It was our second iteration, right? Now our third iteration. So b is 5 here, right? So when 5 not equals 0, right? And temp is getting 5. And a modulus b, that means 6 modulus 5, right? 6 modulus, a was 6, so 6 modulus 5 would be, let's say 1. And a will get 5, right? Okay, so in the fourth iteration, what is b? B is 1. 1 not equals to 0 is true, and temp is, temp would be b, right? Temp would be 1, and a divided by b, right? So 5 divided by 5 modulus 1. 1 modulus 5 is 0, right? It can evenly divide, so 5 would be the result, but 0 would be the the remainder. Okay, so a would be 1, because a is storing 1, temp, right? So temp is 1, a is storing 1 here. So now B is remainder is 0. In B it's 0, so loop will terminate from here, right? So and loop will terminate here, and we will get return A. So A is 1 finally, right? So we will get 1. So for our case, find AB would be equals 1, right? So we will print the number are co-prime for 6 and 35, right? And if it's not, then the numbers are not co-prime. So this is how this code works, guys. You need to visualize the things. Okay, so I hope if you did it in your own, then you must had some uh, confusion in your brain, right? You couldn't you couldn't think that it will take 4 iteration, and it gave you a lot of work. Your neuron of your brain was working. Okay, I hope you did it, guys. Thank you for watching. See you in the next video. So let's just check this program. Okay, so 6 and 35, you see the numbers are co-prime, and if you give any other number, like maybe 18 and 28 or whatever, so these numbers are not co-prime. Thank you, guys. See you in the next video.